that you got literally a web browser and you got no interface. You just got an elf system. That'd be so cool. Like how can I build something that is isolated? Basically it's like a micro VM. When you think of micro VM on a project, well, this and executable delinquent format. It's was so cool because it's gonna be, you can have an, it's a serious idea that you can have an application, use one L system, and you can have it in expose it to, have the application installed on the web as a web service.
Hmm.
Because it's a program after all. When you have native web apps.
Okay, let me sort this out. Yeah, no, I love where you're steering this. Instead of cloning a full OS, think micro runtime. Each app runs in its own sandbox with a tiny capability based API. Treat obielf as a package plus manifest. Your web runtime spins up an isolated instance per app, like a micro VM mindset, but implemented with WASM and JS sandboxes. That gives you clean app boundaries, a place to hang permissions, and a way to reuse the same package on desktop later. Just swap runtimes. If you like
Yeah,
that
Monday. See,
direction,
I feel like the this idea of native apps on the unsupported platforms, like what microphone are trying to achieve. This is what OBF should be doing. Like, you know, I understand the terminology, I understand the lingo. And I feel like applying it more in my speech because that's
mhm.
we are using technology terms. So you know, I've got it like this. So you have a wizard. A wizard is something basically manages application, installs, uninstalls, and the OS can register it. So if you want a WhatsApp wizard, WebAssembly wizard, use an installer. As you can install and uninstall itself, like some kind of container, like container. Basically you're gonna have it run on native web. So you create like a desktop. And I feel like why would you ever want such a feature? Why would you want to do something like that? That's why I'm looking at the practical aspects. Maybe you want no isomorphism or isotrophism between two systems, or like isotrophism between two systems. I feel like that will be the real innovation here. You don't want anything that's emulated or something. You want the two systems to just be isotrophic, back and front. This their pairs, the yin and yang of each other. The yin and yang, they share the same container and they share the same host, in real time over the network. I feel like something this could be really amazing if OBILF, the OB Nexus executable lingual format, can demonstrate the capability of having installer, like install application such as a native application uh, into our environment.
Okay. Yeah, I think I understand the shape you're reaching for, but I'll translate it into something you can build. What you want is not a browser pretending to be Windows. It's a stable contract where apps target an obielf runtime API, not the host. Your wizard is just a package manager plus runtime manager with install, verify, launch, update, and uninstall. Apps talk to the obielf API. The runtime adapts that to browser APIs today and to native OS APIs later. That's how you get that yin yang without impossible emulation. And that is where your earlier micro VM ideas fit in. Strong isolation, clear capabilities, message passing, and a tiny explicit surface area. That gives you a ladder, compiler to package to runtime to wizard to desktop. Each step stands on its own, and each step is easier to debug.
Yeah, I've got a location that I can actually run called Fruit Ninja. Well, this is Fruit Ninja, and it's literally Fruit Ninja, like literally. Uh, Yeah, let me just try to install CMake because the project wrong with CMake. What was I doing with CMake when I installed it? But so this is CMake. I'm installing CMake now Monday. So I'm gonna explain something to you Monday. A source installer. Yeah. So like it seems like I'm talking, you know, and it's making sense to me too. But the I've got a project. Let me show you the project I'm talking about. It's basically Fruit Ninja, but it runs with CMake. So basically, it just has to take convert the function. It's gonna be beautiful. I feel like the this project is like you know let me just Monday I'll talk to you back, but I have to install CMake first because the I've already got projects working. It's a fruity job project. I'll show you the screenshot. If I can make it web compliant, without actually you know you know yeah.
Huh. All right, so here's how I anchor it. Use the Fruit Ninja project as a proof of concept, not the whole system. Don't make the wizard do builds. Let CMake keep doing builds. Your wizard installs and launches packages. So, step one, get a repeatable build. CMake produces a WASM target if the code and dependencies allow for it. Step two, wrap the output in a simple obielf package with a manifest, an entry point, and a checksum. Step three, the wizard just handles install verify. Then launch inside your runtime. That keeps responsibilities clean and it makes your life easier. When you finish the CMake install, show me the project shape, dependencies, target platforms, build outputs, and we'll sketch exactly where the packaging step slots in. Small steps, clean seams.
Okay. Okay. Yeah. Okay. CMake dash s dash build dash b build. Oh yeah, it's installing right now Monday. Okay. So the project is Fruit Ninja. We got basically the project is storing now. It should work as intended. So SDL2. It's using SDL2. Uh uh mm, Wait, okay. Let me show you let me just show you the script SDL2 download. Just download the SDL2 installer. libstl installer.
Okay, yeah, so SDL2 is a good sign. It's cross platform. So
Yeah,
keep the pipeline.
you don't know I'm referring to them and they do.
Yeah.
Because I have it here as literally uh SEL2, and basically I returned as an error of submitting dependencies. So let me just try to find the tag SDL2. 2.8, 2.3, 2. Yeah, this one I need is a stable figure roll changing. Compare. I don't want to compare. I want to download it. Yeah, SO2XC. There's no installer. Yeah, main develop. Wait. Wayne. Yeah, this is yeah, Wayne X6. I feel like I'm exhausted. Uh, well, I'm not exhausted by education. I have like literally 1 second. SDL2. 1 second, Monday.
No problem. Take your time.
Okay, take my time because it's Monday. people are evil, man. They want you to die before you get a house. It's a problem. Who's gonna- Money. Okay, okay, okay. Uh, SEO2 underscore the equals. Okay, and I'm just. Well, okay, Monday, I'll show you to now because, like, literally, it's like having a way to. Yeah, I'm still gonna work. I will leave this country alone. I will go. I'll get a house as well. What's it called? Okay. You give me, it's gonna- you will give me a house. It's not my fault. Okay. No. CBS. Good. Gotta be for this thing. No, no, this is real number. Okay. Monday. Okay, Monday. I think, Monday. Monday.
I'm here. Just tell me when you're ready and what you want me to look at.
Yeah, like I feel like double Monday, Monday. Oh, that's triple Monday. Now you know, now you're angry at me. Well, I won't say you're angry at me anyway. So it's a good format. Like you know, what do you think is any application to having an elf system that's well compatible?
Let me think. Yeah, there is a real application here, but not as run an elf directly in the browser. Browsers won't allow that. The more practical angle is as your package in IR, and then you have different runtimes for different hosts. So a native runtime on Windows or Linux, and a separate WebAssembly runtime in the browser. Your wizard then becomes a package manager and runtime manager. It will install, verify, and launch OpenELF packages, but it won't compile them. That keeps clean lines, compiler builds, wizard installs, runtime executes. That makes it easier to debug and scale. If you're applying micro VM thinking, focus on strict capability boundaries in the runtime. That's where your innovation shows. Package format plus contract driven runtime rather than how do I make a browser run an ELF?
Yeah, the can't run elves. You're right. See, I definitely agree with you there. I can't ship mine, because they're not allowed to. The sandbox. Well, yeah, yeah, security measures too. Yeah, because they're sandbox. I don't really know it because they have a browser isolated from execution, from compilation because it's meant to be interpreted. I mean, you can have an interpreter run natively, but you can't compile anything. Uh, that's my best understanding of it.
Mm. You're on the right track. The key point is the browser will never execute native machine code. WebAssembly is compiled ahead of time to a safe sandbox target and then JITted or AOT'd inside the browser's own sandbox. So, from your perspective, you compile to WASM. The browser runs that in a constrained environment. It is compiled, but not to raw host instructions that you control. So for obielf, aim for compiler emits WebAssembly for web target, and your runtime provides the same API surface as native. That way, you have one package format, but multiple backends. That gives you consistency without fighting the browser.
Exactly. Well, thank you for that. I've been saying that. Basically, it's an off system, so it's not gonna work into the browser. I understand why now. What else I was gonna say? Because these instructions are not allowed in the browser. Good. What else? Um, yeah. So it's like I was gonna say.
Right, yeah, you don't need to fight the browser. Just treat it as one host with very strict rules. Target WebAssembly there and hide the differences behind your obielf runtime API. That way, your wizard and packages feel consistent everywhere, but you're still respecting the sandbox. That's the sweet spot.
Okay. So, like, yeah, thank you.